Welcome students to the series of lectures on statistics. And in the series of lectures in statistics, we have been discussing probability distribution from pretty long period of time. And in probability distribution, we have completed the discrete probability distributions. And we moved into continuous probability distribution where we completed uniform continuous distribution. We completed 3 lectures on normal distribution. And this is the 4th lecture on normal distribution. In the last 2, 3 lectures of normal distribution, we discussed the properties of normal distribution. We discussed why one should use normal distribution with the help of central limit theorem. We understood the central limit theorem, 2 versions of central limit theorem. And this lecture, we are trying to understand the way through which we can forecast or predict with the help of normal distribution. Okay. Now, in this whole lecture, we'll understand 3 to 4 most critical points. The first important point that we'll understand is that area under the curve is equal to probability in the case of continuous distribution. This first point does not have to do anything with the normal distribution. It is applicable everywhere in the continuous distribution. So if the distribution is continuous, then the probability can be found with the help of area under the curve. We'll try to understand this in this lecture. Again, we discussed this in the uniform continuous distribution as well. We'll try to understand a concept of z-score or z-value or z-score, which simply says how many standard deviation you are away from the mean. How many standard deviation you are away from the mean. And the formula for this is if you have a point, then that point is how many distance away from the mean in the terms of standard deviation. So x minus mu upon sigma. And we'll understand that z table stores all the probability. At the end of the lecture, you will understand all the concept. Okay. So don't worry about what is z-score. Don't worry about what is that table. Just keep in mind that these are the pointers that you would understand in this lecture. Now, for any forecasting or prediction, the best way to invoke the concept or make this concept easy to understand is through example. So what we took a very simple example of a stock return. So we are saying that we are assuming that there is a stock return, say Tata Steel, which is normally distributed. We are assuming it to be normally distributed. It may not be normally distributed, but we are saying it would be normally distributed, say. So if it is normally distributed and the mean return of the stock is 10%. So on an average, the stock return yearly is 10% and the standard deviation of the same is what? 2%. So that is the stock return information that we have. Now we know that the stock return is normally distributed. Awesome. Now, as any distribution become or any entity become normally distributed, the forecasting and the prediction becomes very easy. So if you know any entity, either it is normally distributed or t distributed or chi-square distributed or f distributed, the forecasting or the prediction becomes very easy. If you don't know what is the distribution, the forecasting becomes very difficult. Okay. So if you know that this stock return has a mean of 10% and the standard deviation of 2% and it is normally distributed, if you know that, then the forecasting, then the prediction becomes very easy. But how to do the prediction? For that, we'll first try to build up some concept. The first concept that we have to build up is the area under the curve. And we have discussed this concept earlier as well in the uniform continuous distribution. If I ask you, this is a normally distributed curve, doesn't matter it is a stock return, doesn't matter it is rainfall in an area, doesn't matter if it is the GDP growth of a country, whatever it is, what is the total area under the curve? The total area under the curve is 100% because the total area is also equal to the probability. So total probability cannot be greater than 1 or say 100% if you speak in the terms of percentage. Therefore, the total area is either 1 or 100% because that refers to the probability because total area refers to the total probability and total probability cannot be less than or greater than 1. So total area under any distribution which is continuous in nature, irrespective it is normal t chi-square f distribution, it is going to be 100% or 1 because that refers to the total probability. Now, if I say, okay, this is normally distributed, and we know that the normally distributed distribution has a property that the skewness is 0, which also mean that the left hand section and the right hand section are the mirror image. If the left hand and the right hand section are mirror image, then what would be this area? This area is going to be what? This area is going to be 50% because that is a mirror image. And this area is also going to be what? 50% because they are mirror image. If the total sum is 100%, then definitely the line that bisects the distribution into two equal half which is mean, median, and mode in the case of normal distribution, because mean is equal to median is equal to mode in normal distribution. So the right hand section from the mean and the left hand section from the mean is 50%. What it means that, see, assume that the mean return is 10%, which is given in the question that the mean return is 10%. So if the mean return is 10%, so if I say that what is the probability that the stock return will always be greater than 10%, the answer is 50%. What is the probability that the stock return will always be less than 10%? The answer is 50%, because that is the probability. Why that is probability? Because that is the area under the curve that you see on the screen. Okay. Now, so first important thing that you should understand, that the area under the curve tells you the probability in the continuous distribution, irrespective it is normal, t, chi-square f distribution, or uniform continuous distribution. Number one point. So we discussed that point. Now we have to understand something called as z-score. I'm stating a very important statement, so listen very carefully. Whether the mean return is 10% or 15% or 20%, standard deviation is 2% or 2.5%, 5%, 7%, doesn't matter. If you're moving one standard deviation in the left and the right direction, if you're moving one standard deviation left and the right direction from the mean, if you're moving one standard deviation left and the right direction of the mean, then the area under the curve that it covers, the area under the curve that it covers is equal to 68% approximately. Okay. How many standard deviation you have moved from the mean? One standard deviation. So if mean is 10%, and the standard deviation which is given in the question is 2%. So if you're moving 10% plus one standard deviation, that is 12%. If you're moving in the left hand direction, 10% minus one standard deviation, that is 2%, that is 8%. If you're moving in the left and the right direction by just one standard deviation, that the area under the curve will be, this area would be 68%. How would I get it? That's not important. Let's see another example. If I move two standard deviation left and right direction, how many standard deviation? Two standard deviation left and right direction. Two standard deviation left and the right direction from the mean in the symmetric way, then the area under the curve would be 95.4%. The area under the curve would be 95.4%, or the probability would be 95.4%. So basically, if my mean is 10% and standard deviation which is given in the question is 2%, so if I move in the right direction, 10% plus 2%, 2 into 2%, 10% plus 2 into 2%, that is 14%. 10% minus 2 into 2, that is 6%. So the area under the curve between 6 and 14% of the return of the stock return is 95.4%, or you can say there is 95.4% probability that the return would be between 6% and 14%. Okay. Next, if you move symmetrically in the left and the right direction from the mean, about 1.96 standard deviation away from the mean, 1.96 standard deviation away from the mean in the left and the right direction symmetrically, the total area that you would cover is 95%. Or if you move 2.576 left and right, sorry, 2.576 standard deviation or sigma left and right direction from the mean in a symmetric way, then the total area under the curve is going to be 99%. How would I get this number? 95%, 99%, 95.4%, and 68%. How did I get this area? This is coming out of integration. But one thing before moving into that concept of integration, you should understand that what I'm saying, irrespective whatever the mean is, whether the mean is 10%, 20%, 25%, 30%, or the standard deviation is 2%, 2.5%, or 3%, doesn't matter. If you move symmetrically in the left and the right direction, one standard deviation away from the mean, then the area is 68%. Irrespective whatever the mean is, whatever the standard deviation is, if you move two standard deviation left and right symmetrically, then the area is 95.4%. This information of area under the curve is not dependent upon mu and sigma. It is dependent upon how many standard deviation you are moving away from the mean. How many standard deviation you are away from the mean is called as z-score. In a very simple term, it is the distance from the mean, but in the terms of standard deviation. It is a distance from the mean in the terms of standard deviation. So, say this point is x. So, x minus mu is the distance from the mean. But how many standard deviation? For that, you divide by sigma, that is your z-score. Currently, the z-score in this example is 1, in this example is 2, in this example it is 1.96, in this example it is 2.576. So if you know z-score, you can tell the probability. What is z-score? What is z-score? Z-score is x minus mu upon sigma. What is z-score? How many standard deviation you are away from the mean. So x is any point minus mu upon sigma. This is the formula for z-score. Now, the question is, okay, you know the z-score, but how you got exact number of 68% or 95.4% or 95% or 99% for exact value of 1 standard deviation, 2 standard deviation, 1.96 standard deviation, and 2.576 standard deviation? It came from the integration of this probability density function. The integration is not important, but understand, if you have a z-score of 1, you can do the integration on this and you will able to find that whether it is 68% or not. Because if you see this formula, we discussed about this formula, x minus mu upon sigma. If you see this formula, this is what? Z-score. So basically this formula is 1 upon sigma root 2 pi e to the power minus z square upon 2. If you integrate it from minus 1 to 1, for z value minus 1 to 1, you will get the value of 68%. If you integrate from minus 2 to 2, you will get the value of 95.4%. If you integrate from 1.96, negative 1.96 to positive 1.96, you will get the value of 95%. If you integrate at 2.576, you will get the value of 99%. Right? Okay. Now the question is, if you can do the integration, if I can do the integration, the statistician might have done the integration and saved all the integration in a table. That table is called a Z table. So you don't have to worry about integration. What you have to worry about, if you know the z-score, already the integration had been done, and with the help of that integration that the statistician had already done for you, they created a Z table. You just have to look into this Z table and you can talk about the probability or area under the curve. That's it. So this is your Z table. Now, what is important to understand that the center of the Z table, this section of the Z table talks about area under the curve or probability. The top row and the leftmost column talks about Z score. How many deviation you are away from the mean. Okay, so this talks about Z score, the leftmost column and the top row, and this gives you the probability. Let's test it. Before testing the Z table, you also need to understand what is the image here. This image is not identical to the image that we discussed. See, these are symmetrical image. The image which is given in this distribution is saying cover all the area from the left hand direction and move to the right direction. So if you know the z score of the right point, then this table is beneficial for you. Okay, first of all, let's look into this value. This value is saying the z score is 0. What is the meaning of z score is 0? The distance from the mean is 0. So basically you're standing at the mean. So if you're standing at the mean, then the distribution would look like what? This. What should be the area under the curve? 50%. We already discussed this. That the area under the curve from the leftmost tip till this section is what? 50%. That is given there. So all the area under the curve is discussed here. Okay. So if you know this, if you know this table, if you know how to read this table, you would be able to predict the probability. Okay. Let's solve the first question. So basically, the question was that the ITC stock return is normally distributed with a mean of 10% and the standard deviation of 2%. Okay, perfect. Now the first question is, what is the probability that the stock return is greater than 15%? What is the probability that the stock return would be greater than 15%? Okay. So it is saying the value that you are interested in what is what? 15%. So what is the probability that the stock return is greater than 15%? So basically you're interested in this section. You're interested in this section. So you need to know how many standard deviation 15 is away from the mean. So mean is 10%, that is given in the question. What is the distance? 5%. But 5% is the distance from the mean, not in the terms of standard deviation. What is standard deviation? 2%. So 5% upon 2% is 2.5%. Sorry, 5% upon 2 is 2.5. So you're 2.5 standard deviation away from the mean. 15% is 2.5 standard deviation away from the mean. Okay, so z score is 2.5. Let's look for 2.5. Where you get the value 2.5? 2.5 is 99.38. So basically, The area is 99.38, but which area is 99.38? Let's look into the image. It is saying if you start covering the area from the left hand direction and reach the z value of 2.5, then this area is 99.38%. But are you interested in this area? Are you interested in this area? No, you're not interested in this area. This area came to what? 99.38%. So what would be this area? If this area is 99.38%, so what would be this area? This area would be 0.62%. Why? Because the total area in the curve has to be what? 100%. So this area will come as 0.62%. So what is the probability that the stock return would be greater than 15%? Only 0.62%. So if you're interested in earning more than 15%, should you invest in this stock? The answer is no. You would not invest in this stock, right? So 0.62% is the only probability that the stock return would be greater than 15%. Okay, cool. Now the second question is, tell the probability, predict the probability that the stock return will be negative, or what is the probability that the stock return will be less than 0%? This is the second question. Third question is stock return. What is the probability that the stock return will be between 8% and 12%? Now pause the video and solve the question. The only thing you have to change that instead of 2%, change the standard deviation to 5%. That's it. And the cumulative Z table that you have to use is this one because there are different version of cumulative Z table. There is also a version of cumulative Z table which has negative Z score. And you will see this image at the top of those tables. And the table that we are using is the positive Z score table. And the image at the top of the cumulative Z table that we are using is this one. Okay, so with the help of this cumulative Z table, try to solve this question. And if you're able to solve the question that what is the probability that the stock return will be negative and what is the probability that the stock return will be between 8% and 12% by taking the standard deviation is equal to 5%, then you understood the concept of reading this Z table. Okay, now if you haven't understood the concept of reading the Z table, the most important thing that you have to remember that for probability, for forecasting, what you need is Z table, and Z table has all the probability. Okay, with that, we'll end the session here. Thank you. Have a nice day.